is what is a data warehouse. Now, the term is really quite simple. If we just break that term, data warehouse means data plus a warehouse. So normally warehouse means a place where you can have or where you can store huge amount of data so that you can use it in future. Now, data means information or any type of knowledge or data or information regarding the data. Now, data warehouse means a place where we can store huge amount of data. And when it comes to data, that means a sort of information. Now, there are lots of requirement of having a data warehouse. Now, if you go to any shop, you can find an example of a warehouse. If you go to any specific mall or any specific shop, you can find they have a notebook, or now the notebook is obsoleted, so they are having a system where they are entering the information in a file, that how much they have purchased, how much they have brought into their shop, what are the products which are sold today, all those informations. Now, these informations are really required when you want to do some predictive analysis or when you want to do some historical analysis. Now, that's why data warehouse is very much essential nowadays. And if I take a simple example of data warehouse, let's consider the Facebook one also. Now, Facebook is also having a data warehouse, so where they will store all the activity of a particular user. Now, can you please mute yourself? Okay, thank you. So, data warehouse, Facebook have its own data warehouse where it store all the activity you're done by a specific user. So we will go through the data warehouse what Facebook is using and how it is using in the next slides. So let's go into data warehouse. So data warehouse it's just only a database, but it having a structure which is quite huge than a specific database. Database is meant for small amount of customers. It's meant for for a specific. If you are running a shop, then you need a specific database to handle all your information. But if you are handling a company, or you are having millions of records to be handled on a daily basis, then you need a data warehouse, because the processing of those huge data cannot be possible in a database. So that's why we are having a data warehouse. Now let's go into the definition of data warehouse then. Now, data warehouse is a database which is obviously it's a huge in size. Along with that, it has few properties. One is it's subject oriented. Data warehouse is integrated. It's time variant, and it's non-volatile. Now we will go through each of its characteristic, or each of the property of data warehouse. Now, first thing is subject oriented. Now, why the data warehouse is called subject oriented? Now, in the picture, you will be able to see that I'm having a sheet which contains sales channel, quantity sold, part number, date, customer name, and all those attributes. This is a simple transactional file. Now, subject-oriented means when you are classifying those information based on some specific taglines. Now, the first four items in fact, sales channel, quantity sold, part number, and date. Now, all those attributes specify to a specific cell. So if I tag it to cell, then it will be easy to identify those particular attributes. Now, customer name and its mailing address. These are the two attributes which is specific for a customer. Now, it cannot be linked to a cell. It cannot be linked to a cell directly. But if someone asks that what is this attribute, then definitely the answer will be it's an attribute of a particular customer. Similarly, the unit price, the part number, product description, all those informations are attributes. All those informations are attributes of a specific product. Now, this is what subject oriented. In data warehouse, we will be having the transactional data, but it will be tagged to a specific subject area. It may be a cell, it may be a customer, it may be a product. So in data warehouse, data are stored on the basis of some specific subject area. They're not stored in this transactional file. Rather, they will be stored on basis of the specific subject area, so that it will be easy for someone to identify what are the data specific to sales, what are the data that is specific to customer, and all those stuff. Now, the next property of data warehouse is it is integrated. Now, why it is called integrated? Suppose you are having a data warehouse which gets data from 3 different sources. Now, you have a database where you store the information in a you have a database where you store your cell information. Now, you have a flat file inventory where you store the information in a CSV file, and you have a mainframe system. Now, you have 3 different systems from where you are sourcing the data for the data warehouse. Now, if I take a specific attribute, suppose say product or product ID to be very specific. Now, the product ID may be stored as a string in a flat file, but it may not be stored as a string in the database. Let the product ID be an integer in a specific database, and it is having a different data type when it comes to mainframe. But when it comes to data warehouse, all those 3 different data types will be converted into a standard data type. So when you go to data warehouse, you may not find product ID with character as well as integer as well as data type stored in mainframe. You will be having a standard structure here. You'll be having a standard data type. So that's why it is called integrated. So data warehouse will integrate the 3 various product or various attributes and store them into a standard format, so that it is easy to run the query and easy to access the data. So that's why it is called integrated. Now, non-volatile. Now, why it is called non-volatile? When we have a database, when we have a transactional system, there the records are getting inserted or updated on a regular basis. Now, if you have a specific product, then that if you have a specific product and the product price changes, then you will update that particular uh, or delete that particular record from your transactional system. But when it comes to data warehouse, the records will never get deleted. Once the data come into data warehouse, the status may change, but it will be kept in the data warehouse. There is no process of deleting the data in data warehouse. There may be a flag or maybe some attributes to identify that yes, this is the data which is present recently, and this is the data which is deleted. But it will that means there will be a soft deletion process. There will be no hard deletion in data warehouse. That's why it is called non-volatile. Next is, now, what is time variant? As we have discussed, data warehouse store huge amount of data. Now, in a transactional database, you may be having a smaller or the most recent data. But when you go into data warehouse, you will see all the information, all the history of a particular record. Now, why it is called time variant? Because it not only stores the recent data, it may not be the most recent one, but maybe the previous version of the record. Along with that, the history of a specific history of for the data. Now, why we need those history? Now, if you are a manager of a specific finance company, then you want to know that what are the things driving your company in a profitable direction. Now, for an example, let's take a small example of a shopping mall or a shop. Now, transactional data will store what are the products that are purchased. Hi guys, can you please mute yourself? Okay, thank you. So transactional database, suppose you are running a shop, then what are the products sold for a particular day you are having in that. You are having those informations in a transactional database. Now, if you want to know that which product was sold the most in a specific month, then you may not find that in a transactional database, as there is huge amount of transactions, and if you try to fetch that information from a transactional database, then it may hamper the database performance. Now, guys, I would request to please mute yourself. I'm hearing some sound in the background. Okay, so in data warehouse, yes, so if you want to know that which particular product is sold the most, or which particular product is not having that much favorite in terms of its purchase, then you definitely have to go to the data warehouse to check its purchase history. Now, we can't query those information in a transactional database, because transactional database is used for your daily transaction. Now, just imagine if you are trying to fetch that that information, that how many products were sold in a specific month, and at that time, at that point of time, you are entering something in a transactional database, it may impact your performance because the database is busy in providing the result of that particular query which you have fired. So that's why what we have. That's why what most industry do is they move their transactional database into a separate one, so that it will not impact the query performance. So this is the difference between a transactional database and a data warehouse. I think this clarifies why it is called a time variant. Let's go to the next slide. Now, what is a data mart? Now, in the first slide, when we are discussing subject area, the sales, customer, product, all those stuff. Now, that is basically an example of data mart. Now, what data mart does is it will convert the data inside the data warehouse into a specific subject area. Now, for an example, suppose you are working in a company where you are having 3 teams which do the analysis or do the reporting. Now you have a marketing team, you have a customer team or customer management team, and a sales team. Now the data in data warehouse is very huge, but the data which the sales data maybe it may not be required by the marketing team, and the data which is specific to marketing may not be required by the customer demographic team. So that's why concept of data mart come. Now what data mart is, it convert the whole data warehouse into some chunk of the information which is specific for a specific user. Now if you see, we are having the data mart inside the data warehouse. Now it can be outside the data warehouse so that it can be used by a specific user. Now the marketing team will, it's not required for them to go into data warehouse and filter those marketing data. They can directly go to the marketing data mart and use the query there so that they will get the required information. Similarly, the sales team, they can only go to the sales mart and use their query to get the required information. Similarly for the customer management team. Now that's why when you have this scenario that you are having different team to handle in a specific company, then it's better to build data, smaller data marts rather than a huge data warehouse. Okay, so when we are discussing about the characteristic of data warehouse, we come to know that data warehouse is time variant. Now this comes to the concept of OLTP and OLAP. Now what is OLTP and what is OLAP and why we need it? Now OLTP means online transactional processing. Now OLTP is a place where large number of transactions happen. That is, there may be an insert, maybe an update, maybe a delete. Now this is an example of a shop. When you are running a specific shop, then you may be having a OLTP system. So what OLTP does is it should have a fast query processing. I mean, when you are having a transactional database, you obviously want, when you query it, you will get the result instantly. For an example, suppose when you are going to the ATM machine and giving your card details and your PIN number for a statement, it reflects in a specific monitor, or it gives a sleep. Now, if it is not that fast, then after entering those information, you need to wait for some time in order to get those information. Now, that may be a bit difficult if you are not getting the response quickly. So you need to have a OLTP system which is fast. Now, if you try to get a report or get a specific information from a database, then it impacts the transactional data or the transactional processing. Now, if you are querying a huge, if you are running a huge query in a transactional database, it may hamper the day-to-day processing of day-to-day activity of a specific transactional database. Now, here the effectiveness of OLTP system is measured by the number of transactions per second. Now, you obviously want the system to run faster. When you fire a query, it should give you the result instantly. So that's why OLTP systems are for only the front system. That means when you are running a shop, when you are running a specific UI, all those information you need a OLTP system. Now, OLTP system follows third normal law. If you want, we can have a when we are discussing about in the next class, we can go through what is the third NF. We will discuss what is normalization also. Now, what is next is what is OLAP. OLAP means online analytical processing. Now, this is basically for those who are involved in some sort of reporting, some sort of analysis. Now, data warehouse is only meant for online analytical processing. Now, if you want to know that how many products are sold for a specific region, or how many products are purchased by a specific customer, then you can't go and check that in a OLTP system, but all those informations are stored in a OLAP system. Now, the queries that are used for a OLAP system is quite complex. You want to know that what is the revenue percentage, how the revenues are getting increased, how they are getting decreased, and all those informations. Now, for this particular information, you need a OLAP system. Now, OLAP applications are widely used by data mining techniques. Now, the question is, what is data mining? Data mining means finding a specific pattern from a set of data. Now, if for an example, if someone sees your credit card bill, and if you find that on a monthly basis you are having transaction from different restaurant, then he can assume that this particular person is likes to eat outside or eat in the restaurant. Now, finding those types of pattern from a specific set of data is called data mining. Now, there is a fun example for our data mining process. In a US-based company which runs a specific shop, they have done is they have done some analysis. So what they have done, they have collected all the transaction history, all the sell, all the purchase that is happened for a specific month in the specific shop, and from that data they they have found a very funny pattern. I think everybody is aware of that example. They found that those persons who are purchasing a diaper on Thursday, they are purchasing a beer with that. So this found fun. Sounds funny, but yeah, that's true. And after that, what they've done is they have just placed the both the sections adjacent to each other. So they have placed the beer section inside of the besides the diaper section. You can't imagine, after doing that they have got a revenue that is 5 times their normal revenue. So they haven't done anything big. They just collected the information, find the pattern, and implement the process. So that is called data mining process. Now this OLAP, or online analytical processing, or analytical processing, will not only help you to find out what happened in the history in the past, but also helps you take some decision for the future. That's a OLAP. Next is, what are the architectures that we normally follow in a data warehouse? Now, there are commonly 3 types of architecture that we follow in a data warehouse. One is the basic one. Next one is data warehouse with a staging area. Now we will discuss what is a staging area. Next is data warehouse with staging area and a data mart. Let's go to the first one, the basic one. So here you can see we are having 3 different sources, 3 different operational systems. From these systems we are loading the data into a data warehouse, and from the data warehouse we are having 3 different types of users. Set of users which are doing the analysis, set of users which are doing the reporting, and set of users which are doing the data mining. So this is the basic structure of data warehouse. Now next is data warehouse with a staging area. Now if you see, this structure is exactly similar to the previous one, but only having a staging area. Now the question is, why we need a staging area? What is the requirement of a staging area? Now suppose you are running a company which brings data from 3 different regions. Now let all the 3 data are not available at the same time. Now data from first operational system is available at 9 AM. The data from the second operational system is available at suppose 11 AM, and the flat file information is available at suppose 1 AM. Now, if the 3 source data are available at 3 different times, the 3 system of data are available at 3 different times, then it will be difficult for you to process those data into data warehouse. So what it does is, um, in that particular staging area, it will help us to stage the data. That means if the first system is available at 9 a.m., if second is available at 10 a.m. and third is available at 11 a.m., then what the staging area does is it will bring the data from the three different source systems into this common location, into the staging area. So after that, when data from all the three systems are available, then it will start the processing into the data warehouse. Now, this will help us to get our data warehouse processing a bit easier. Now, imagine if you are getting the data, first data at 9 a.m., then you need to process the data first. After that, again, you need to process the data which is available at 10 a.m. and so on. And it will be very difficult when you are, and after that, you need to join the data to show that all those information which are processed at different times are needs to be stored in a single table. It will be very difficult to do that. So that's why we need a staging area. So after that, the process is it's similar. We are having the analysis team, we are having the reporting team, we have the mining team to process this information. Now, next is staging. Next is architectures with a staging area as well as a data mart. Now, what is when we know what is a data mart, right? So here you can see that the data is there in the source system. It is processed into the staging area and then to the data warehouse. And from the data warehouse, the data are split into three different data marts. Now here you can see there is a purchasing data mart, there is a sell data mart, and an inventory data mart. So here in that particular example, if someone wants to get the information for purchasing, then he just need to go to the purchase data mart. It's not required for him to go to the sell data mart or the inventory one. Similarly, if someone is interested in sell data, he just needs to go to the sell mart. So this is the third type of architecture. Next is the schemas in data warehouse. Now, what are the different schemas that are followed in a data warehouse? Now, what a schema means? Now, schema is just a blueprint of a specific data warehouse. Now, if you are building a specific construction or you are building a specific structure, you need a blueprint or a specific when we say that schema, it's just a blueprint of a specific data warehouse. Now, in current data warehouse structure, we are having three types of schema that are normally followed. One is the star schema. Next one is the snowflake schema, and the third one is the fact constellation schema. We will go through each of those schema with examples of what are the terms that are being used in a specific specific schema or a specific warehouse. What is a fact table? What is a dimension table, and what is the different fact tables that is currently used in a data warehouse, what is the different dimensions that are being used in a specific warehouse, all those information. Along with that, we will come to know what is a slowly changing dimension, what is a type 1 dimension, and all those information. And after that, we will jump into the practical one, so that we can do some stuff in our Informatica structure. So with this, I end the first session of Informatica. If anybody have any questions, just you can